Okay, let's look at second-degree polynomials. And we want to take note of three characteristics of these second-degree polynomials that will help us to understand them. Now, when I talk about a second-degree polynomial, here's a real general way to write one. Ax squared plus bx plus c, where a does not equal 0. Now, b could and c could, but this is a second-degree polynomial, and this is a most basic one right here, y equals x squared. And we know what the graph of that looks like. Notice it has a vertex down here at 0, 0. So very straightforward. Now, if we add a number onto the end, look what happens. It shifts up, it's shifted up this amount. So it shifted up 3 units. Now, notice we could get a horizontal shift by putting a -2 in here with the x. So instead of just x squared, we have x minus 2 squared. So now we have a polynomial that has been shifted up 3 units and then to the right 2 units. And that's the vertex. Now, let's look at this. So let's suppose that we have a second-degree polynomial in this form. I'll call this the vertex form of the polynomial. And I call it that because we can easily see what the vertex is. Notice that the graph of x squared has a vertex at 0, 0. But if we shift it up k units and then a horizontal shift of 8 units, we can see that the vertex must be hk. So if we have a polynomial in this form, we can immediately tell what the vertex is. For example, look at this one. It's been shifted down 9 units and to the right 2 units. So when we talk about a second-degree polynomial, the vertex is one of the things that we're interested in. And it's helpful if we can just look at the expression, the mathematical expression, and tell, just eyeball it and tell what the vertex is. In this case, 2, -9. Now notice, we get the x-coordinate of the vertex from the parentheses with the x, only it's the opposite. See? We get the y-coordinate from just outside here in the k position, right? So we get a -9. So the vertex is 2, -9. Now, also, we're interested in the y-intercept. So the vertex, the y-intercept, something we're interested in. The y-intercept is what we find by letting x be 0. Because when we talk about the y-intercept, we're talking about where this graph crosses the y-axis. Well, that happens whenever x is 0. So we put a 0 where the x is, and we just do the arithmetic here. -2 squared is 4. 4 minus 9 is -5. So there, that is our y-intercept, right there where it crosses the y-axis. Now, we're also interested in the x-intercepts. Now, sometimes I'll call this the zeros, and sometimes I'll call these the roots. But x-intercepts, zeros, and roots. In this case, I'm calling it the x-intercepts because we can clearly see that it crosses the x-axis. So, and I just talked about the y-intercept. But anyway, the way we find that is we let y be 0. Okay? We just take the whole expression here and set it equal to 0 and solve for x. So I'll bring the 9 over. See? Dig how I brought the 9 over. Then I square root both sides, and I get that x minus 2 is plus or minus 3. Or if I brought the 2 over, 2 plus or minus 3, and I get -1, 0. That's a x-intercept. And I get 5, 0. That's another x-intercept. So these are the two x-intercepts. So what we're interested in when we study these things, we're interested in the y-intercept, the vertex, and the zeros. In the previous problem, I called those zeros the x-intercepts because in this case, the graph did cross the x-axis. But the zeros are found exactly the same way as the x-intercepts. Now, let's look at an example here. Let's suppose we've got this one. Okay? Now, here we have a shift horizontally to the right 2 and a vertical shift down 16. If we want to find the y-intercept, we just replace the x with 0. Going through the arithmetic there, we get that the graph crosses the y-axis at 0, -12. Now, for the vertex, we don't have much to do if we've got it in this form. We just look at it. It's 2. Now, if this had been x plus 2, that would be -2. We get the x-coordinate from the parentheses with the x, only the opposite. We get the y-coordinate from what's on the outside, exactly that. Now, the zeros, that's when we set the whole thing equal to 0. Okay, I let y be 0, and I solve for x. See, and just going through it, I've got x minus 2 squared equals 16, square root both sides. And there we have it. X equals 2 plus or minus 4. Or another way to say it is the x-intercepts would be -2, 0, or 6, 0. Those would be the x-intercepts. Okay. Now, let's look over here at this one. We find the y-intercepts. Now, this one, it's very easy to find the y-intercept. You just replace the x's with zeros and you get -3. So very straightforward to get the y-intercept. To get the zeros, it's not bad. We just take the function, this thing, set it equal to 0, replace the y with a 0, and solve it. Now this one we can solve by factoring. For these second degrees, we always have the quadratic formula on standby if we need it. But if we can factor pretty quickly, we can go ahead and factor. And the idea with factoring to solve this is we know that if a product of two things equals 0, like this, a solution would be if either one of them equals 0. In other words, if x equals 1 or if x equals -3, both of those are solutions. So two things multiplied together can't be 0 unless at least one of them is 0. So either x minus 1 equals 0 or x plus 3 equals 0. That means that x equals 1 or x equals -3. Those are the zeros. And these are the x-intercepts here. Okay, that's where it crosses the axis. Now, as far as the vertex goes, well, this is not in that form. This is not in the vertex form. But we can put it in the vertex form this way. Let me rewrite this. I've got x squared plus 2x plus a blank here. I'm going to put something in this blank and then -3 here. See, I just put two blanks in between. And what I'm going to do is I'm going to take 1/2 of this x term, this x coefficient, and then I'm going to square it. Now, 1 squared is just 1. And I'm going to add that. I add it right here to this. Now, that can't stand as it is. I can't just willy-nilly add things. I've got to remember if I add something, I need to subtract it off. So really, I've done nothing. And you may think, well, why in the world did you do that? Well, I did it for this reason, because what I've done here is I've performed this operation called completing the square. And I've made this x squared plus 2x plus 1 so that I could write it as x plus 1 squared. See? X plus this number right here squared. And then, of course, over here I've got -3 minus 1, -4. So what I've done is I've completed the square for this x squared plus 2x. That means I can factor this. If you factor this, it would be x plus 1 times x plus 1, which is this right here. So now it's easy for me to get the vertex, the x-coordinate from the parentheses with the x, only the opposite, and the y-coordinate from over here, -4. Yeah, no worries. Okay, now let's look at this one. This one looks a little more challenging, but let's just go along as usual. Remember, we're interested in the y-intercept, the vertex, and the zeros. So the y-intercept, just replace the x's with 0, and we've got it, 0, 1. The zeros, I just need to set the thing equal to 0, right? Replace the y with a 0, and this one factors. and I get x equals -1/2 or x equals -1. Okay, now let's look at the vertex part. Actually, and there would be the x-intercepts. Now let's look at the vertex part. Now when I go through this completing the square operation, before I do that, what I need to do is I need to make sure that I just have 1x² here. Okay. So I'm going to factor out this 2. So see, I factored out the 2, and instead of a 3x, I have 3/2 x to counteract the fact that I factored out a 2. Okay? So I factor out the coefficient of x² first, then I take half of that 3/2, and I get 3/4, and then I square it, and I add it here. So I took half of the 3/2 right here, and I squared it. Now, I put a 9/16 in here, but you have to realize there's a 2 in front. So really what I've done to this thing is I've added 2 times 9/16. So when I counteract that by subtracting off something, I'm not going to put a 9/16 in here. I'm going to put 2 times 9/16, which is a 9/8. See? So I subtract it off. Okay? Well, now I'm ready to rewrite this as I can complete the square as x plus this thing. Whatever half of this was, that's what goes right there. So I've got 2, and then this whole thing right here is x plus 3/4 squared minus this thing right here. 8/8 minus 9/8 is -1/8. So now I've got my vertex to be -3/4, comma, -1/8. And that is how we can find these 3 parts: the y-intercept, the vertex, and the zeros.